Good morning, everybody. Let's talk about the homework. Okay, we had 18 through 30 on page 284. And so get it out and let's take a look at it. This stuff is pretty simple. Hopefully you didn't find it too difficult. And so here we go. This first one says, okay, find the measure of angle ACD. Well, we don't have any information on angle ACD, so we got to look at what information do we have. And it says this is a rhombus, so that's super important. So if this is a rhombus, the diagonals bisect the angles through which they pass. So therefore, these two angles right here would have to be congruent, okay? And then just over here, these two angles would be congruent. So that might be helpful. And so if that's the case, and the other thing we know about a rhombus, what do we know about the diagonals of a rhombus? And that would be that the diagonals are perpendicular. So let's kind of zoom in for a second and think about what we have going on here is in this situation, we have a right triangle because this is a right angle, okay? We know that whatever measure they gave us for this angle applies to this one over here, and whatever information they gave us about this angle applies to this one right here. So now we've got a right triangle, and we have information about two of the angles, and the other one is the 90. So then think about that. Those two must add up to be 90. So we could write it like this. We could say, well, I know that 7x minus 6 plus 4x minus 3 plus that 90 degrees all must add up to be 180. Okay? Because that accounts for all three angles in the triangle. Now, I know I made kind of a mess here, so let me try to look at that again. So I'm saying that 7x minus 6, that would be this angle right here. The 4x minus 3, that would have to be the same as this angle right here. And then the 90. That would be this right here, okay? So those are the three angles within that triangle. If you didn't catch why this is for this angle, it's because, you know, the diagonals bisect the angles through which they pass. So these two angles have to be congruent both here and here. And these two angles here and here have to be congruent. So with that in mind, I can move forward. 7x plus 4x is going to give me 11x minus 9 plus 90 equals 180. So you combine the 9 or the negative 9 and 90, you get 81 equals 180. Subtract the 81, you get 11x is equal to 99. Divide by 11 and x is 9. But that's not the answer. I'm not done because the question was, what's the measure of angle ACD? Okay, ACD. Again, let's kind of get rid of some of all this extra stuff. Okay, so ACD is right here. I plug in the 9, and 7 times 9 is 63. Minus 6 would get me down to 57. Okay, so the measure of angle ACD is 57. Measure of angle ABC. ABC is right here. Okay, well, think about it. ABC is going to be in a parallelogram, which a rhombus is, opposite angles are congruent. So whatever all of this is, all of this must be. So I can plug into this, my 9, and get 4 times x is 36 minus 3, and I get 33. So that's this angle right here. And right next to it would be 33. So this whole corner would be 66, meaning that this opposite corner, ABC, would have to be 66 degrees. And then lastly, the measure angle BEA. Measure angle BEA. Well, that's an easy one because we know that the diagonals of a rhombus are perpendicular. So BEA has to be 90 degrees. That's easy. Okay, next, number 21. Okay, this one again, it's a rhombus. Let's look at the information we have. We know in a rhombus, the diagonals are not only perpendicular and they bisect the angles through which they pass, but they bisect each other because it is a parallelogram. And so for this one, let's see what we've got here. It's asking, we know that this piece would have to be the same size as this piece. Okay, so we could say that 4x minus 7 is equal to 2x minus 1. Subtract the 2x from both sides, and then add the 7 to both sides, and divide. Okay, and so then I've got, I know that this, 2 times that 3 would be 6, minus 1, that'd have to be 5. I could double check, make sure this one is the same. 4 times this 3 would be 12, minus 7, again, would be 5. Okay, so we know that this piece, QT, is 5, and QS would have to be all the way across. That would be 10. So I know QS is 10. I can go ahead and write that. Excuse me. And then I can plug in the 3 for this piece right here. 2 times 3 is 6. 6 plus 2 more is 8, which would make this other part 8. And it asks for how big is TR? Well, TR is 8. But then it asks for PS, which is this part right here. You go, okay, so how do I figure out that? And hopefully you remember that we talked about that we have a right triangle here, and we can use the Pythagorean theorem, okay? We could say that we know that a squared plus b squared is equal to c squared. And we know that this always represents the c, the side opposite of that 90. So let's see, a is 5, right? We'll say 5 squared plus b would be 8 squared equals c squared. That's the unknown. So that's 25 plus 64 is equal to c squared. And if you really only take it about that far, you get that c squared is equal to 89. So therefore, c is equal to the square root of 89. All right? And I'm okay if you left it there. It says round to the nearest tenth. It's okay. This is an exact answer. If you did square root of 89, that's absolutely fine. Okay, next, number 24. Okay, this tells us this time it's a rectangle. We're dealing with a rectangle, so we got to think about what special information do we know about a rectangle. The diagonals are congruent. They bisect each other because it's a parallelogram, but the diagonals are congruent. Let's see here. So I know that this piece has to be the same length as this piece because that's what it would mean for diagonals to be congruent. And let's see what information it asks. The measure of angle GHK. So GHK is this angle right here. So if we think about that, we go, well, we got to kind of apply the situation. We know that a rectangle has a right angle in every corner. So if that's a right angle, then we know that this part of it right here is 52. Then this part over here must be 90 minus 52 have to be what this is. 90 minus 52 is 38. Okay, and so therefore that part right there must be 38 degrees. Okay. And so if that's the case, now you go, well, that's not the angle we're looking for. Well, what I wanted to do is, remember, these diagonals bisect each other, but they're also congruent, which means that this side is the same length as this side. So that right there is an isosceles triangle. So if this is 38 degrees in this bottom, then up here is 38 degrees as well. Okay. So measure angle GHK, 38 degrees. Measure angle HLJ. HLJ is right here, okay? We go, well, what would that be? Well, a couple different ways of figuring it out. But as I look at it, I think one of the easier ways would be to go, well, let's think about what we know. This is 38. This is 38. Okay, so 38 and 38 is 76. All three angles must add up to be 180. So this one has to be 104 right here up in this top corner. But we're asked about HLJ, which is this one. Well, these two angles are supplementary angles. So we can take away the 104 from 180, and that's going to give us 76 for that one, okay? And so the measure of angle HLJ is 76. All right, now let's do GJ. GJ is one of those diagonals, and to do a diagonal, we know the diagonals are congruent of a rectangle. We're going to use the Pythagorean theorem, okay? So we know that 7 squared plus 10 squared is going to be equal to whatever that other side is squared. That's 49 plus 100 is equal to x squared. So therefore, x squared is equal to 149. X is equal to the square root of 149. Okay, and there you have it. So GJ is equal to the square root of 149. HL is going to be half that. Is equal to the square root of 149 divided by 2. Okay, all right. Last little set of problems, and again, so now what do we have here? It says find each length and value for the square. So this time we're mixing a rhombus and a rectangle. We're getting a square. And so if it is a square, think about some of the things we know. All right. It says that every side is 4. This is 4, this is 4, this is 4. And from that, we can figure out how big one of these diagonals have to be. Because again, we have right angles in the corner. So we would know that 4 squared plus 4 squared is equal to whatever that diagonal is squared. So that's 16 plus 16 is equal to x squared. X squared is equal to 32. So therefore, x is equal to the square root of 32. And that number is, somewhere in between 5 and 6, pretty close to 6. But SV is only half of that. So that would be the square root of 32 divided by 2. I'm not using a calculator in front of me at the moment, so that answer will have to do. It's going to be smaller than 3. That's what I know. Not bigger, in between 2.5 and 3. Okay, and then the measure of RT, well, we just did that one. That's the square root of 32, which is a little bit less than 6. Perimeter of RVS. RVS, that triangle right there. What's the perimeter of triangle RVS? Well, you've got think about the sides. You've got one side is 4, one side is half of square root of 32, another side is half of square root of 32, and that's what the perimeter would be. And so it's 4 plus the square root of 32. And what is that? Well, it's a little bit less than, a little bit less than 10. Just a little bit less than 10. Okay, so P is a little bit under 10. So I can't remember if I asked you to do number 31 or not, but let's take a look at it. It's a problem that's really easy to overcomplicate, okay? Immediately, you can be thinking about, man, we got right angles and we can use Pythagorean theorem. There's all sorts of stuff going on, and that's true. But you got to come back to the basics. What do we know about a square? What do we know about the diagonals of a square? We know that they are congruent and they cut each other in half. Okay, and so this piece right here is the same size as this piece right here. They're both 16. And I know that because the diagonals of any parallelogram bisect each other. Okay, and if all of the stuff is, if we've got this isosceles triangle and this thing's been cut down, then if this is 10, then this part right here is 10. But the thing that's real easy to miss is that this whole thing has to be how long? Well, that whole thing has to be 16. Why? Because the diagonals of a rectangle, which a square is, are congruent. And so if this part right here is 10, then this part right here must be 6. So GC is 6. It's a crazy easy problem. I was getting ready to start doing Pythagorean theorem and crunching all sorts of numbers, but in the end, it's really, really simple. You look at what you do and you go, okay, I know that this piece is 16, so therefore this piece is 16, this is 10, so that leaves 6 right here. Okay, really simple. So GC is 6. All right, I hope this helped. Look forward to working with you guys soon.